Assalamu alaikum everyone. I'm Nazmus Sakib Razin and I'm from Group 8. For our assignment 2, I have chosen Mission 3, Pulse Modulation and Multiplexing. Let me introduce to my group mates. Myself, Nazmus Sakib Razin, Muhammad Ayman Nazmi, Muhammad Zamir Faik, Muhammad Alif Ismat bin Abdul Rahman. Pulse modulation. Pulse modulation is a type of modulation in which the signal is delivered in pulse. It is capable of transmitting analog data. Continuous signals are sampled at regular intervals in pulse modulation. There are two types of pulse modulation, analog and digital. Number one, pulse amplitude, PAM, pulse width, PWM, pulse position, PPM. And for digital modulation, it's pulse code, PCM, and delta, DM. Frequency ranging from 20 Hz to 20,000 Hz can be heard by the human ears, 2K Hz. When converting analog to digital, we just need to encode enough to provide a decent digital representation of the speech to make it heard at the receiver end. The voice frequency band simple in telecommunication is 300 Hz to 3.4K Hz. For the sampling, the signal is sampled at regular intervals such that each sample is proportional to the amplitude of the single signal at the sampling instant. The sampling process requires two inputs, which is analog signal and sampling pulse. The input will through the AND gate and produce pulse amplitude modulation as output.
Alright, next is sampling rate. The sampling rate is the number of audio samples collected each second measured in hertz or kilohertz. 10 kilohertz sample rate, as for example, equals to 10,000 samples captured per second. We must optimize the sample rate because we want the sampling rate stay low and still retain an appropriate digital reproduction of the sound. The goal of digital encoding is to reduce the sample rate as much as possible while preserving a reasonable digital voice reproduction. Next is pulse width modulation, or PWM. In this type, the amplitude is maintained constant, but the duration or length or width of each pulse is varied in accordance with instantaneous value of the analog signal. For the negative side of the signal is brought to the positive side by adding a fixed DC voltage, as we can see at the diagram for analog signal and with modulated pulse. And then for the quantization, when encoding analog signals, we use the bit level that is closest to the analog signal level at the same time. This process we can say that as quantization. Quantization is a process of encoding a sample of audio to digital. Okay. For the pulse code modulation, or PCM, analog signal is converted into digital signal by using a digital code. Voice frequency band is 4 kilohertz. By using sample theorem, sample rate 2 times with 4 kilohertz, we can get 8 kilohertz sample rate. And then by using 8-bit depth, bit rate is equal to 8 bit times 8 kilohertz is equal to 64 kilo bps. A digital signal is described by its bit rate, while analog signal is described by its frequency range. Okay, as we can see at the diagram. Okay.
Okay, next is multiplexing. Multiplexing is a set of techniques that allow the simultaneous transmission of multiple signals across a single data link. Multiplexing is done using a device called multiplexer or mux that combine an input line to generate one output line, for example, many to one. At the receiving end device called a demultiplexer or demux is used to separate a signal into a component signal. For example, one input and several output, which is one to many. So there are two types of multiplexing, which is analog and digital. For analog, we have frequency division multiplexing (FDM) and wavelength division multiplexing (WDM). And for digital, we have time division multiplexing (TDM). First, frequency division multiplexing (FDM). FDM is an analog technique. There is a signal of a different frequency combined into a composite signal and is transmitted on the single link. The bandwidth of a link should be greater than the combined bandwidth of the various channels. Each signal is having different frequency, and the channel are separated by a strip of unused bandwidth called guard band to prevent the overlapping. Next is wavelength division multiplexing (WDM). The WDM is also analog multiplexing technique. It is working is same as the FDM. In different signal are optical or light signal that are transmitted through optical fiber. A various light wavelength of different source are combined to form a composite light signal that is transmitted across the channel to the receiver. At the receiver side, this composite light signal is broken into a different light wave by the multiplexer. This combining and the splitting of the light wave is done by using a prism. Prism is a band beam of light based on the angle of incidence that and the frequency of the light wave. And next is time division multiplexing (TDM). TDM is a digital multiplexing technique. Each channel or link is not divided by on the basis of the frequency but on the basis of time. Total time available in the channel is divided between several users. Each user is allocated at a particular time interval called time slot or slice. In TDM, the data rate capacity of the transmission medium should be greater than the data rate required by sending of the receiving device.
I would like to explaining about signaling system 7, which we can call is SS7. So in SS7, there will be an in-band signaling. So what's the meaning of in-band signaling? Calls are traditionally placed across branches. Essentially, the dial pulse is sent over the same channels as the voice. It is inexpensive, yet it is susceptible to hacking. Also, the transmitting of metadata and controls information in the same band on the same channel as data is known as in-band signaling. And next, we have out-of-band signaling. This creates a signaling network independent from the voice network. The SS7 optimized network used while also increasing client income. This has enabled signaling information interchange without the need to initially seize a voice channel. Because the customer cannot access the signaling system, it is more secure. We now have additional service such as call forwarding, voicemail, and call in waiting thanks to SS7. Recent advancement on telecommunication. So, connectivity technologies. So this is one of the example for the modern telecommunication, which is Ethernet. that is easy to implement, cheap and high bandwidth, low power wide area networks, wired and wireless communication, RFID, Bluetooth, and high quality digital data such as videos. One of the conception is we can deal with accessories later, which is think about your laptop right now. So you have a laptop, right? How important are things like your charger, mouse, and headphones? Without them, your laptop's performance simply isn't the same, and it may not even work at all. Whether you decide to rent or own your radios, take the time to consider what types of accessories you will need, from charging station for multiple radios to earpiece and headsets. These accessories will help customize your communication experience just for you and your specific needs, and ensure you and your team can stay connected and efficient at all times. The second misconception is technology is ruling our daily lives, and so technology is bad. What people don't realize is that they let technology do this to them. As soon as your phone vibrates, you are distracted from what you are doing and bow down to your phone to check the notification. You could just turn off the notification. The truth is, technology is very powerful. You can share knowledge with the world. You have news at your fingertips, and people collaborate around the world to find cure for deadly disease. So technology is not bad. One should be conscious and use technology rather than letting technology use them. And thank you.